So we just came back from lunch, and before we continue with where we're at, we were just watching a video to just reinforce switch inputs, right? And this is a Volkswagen GTI with a cooling fan, and I had mentioned at the beginning I was having you guys watch it, and I asked you what the switch input design was, and you guys told me pull up. So I want to check you on that first, and what I'm going to use is my desktop program. This is an old Shopkey is the product, and this is actually Mitchell. If you guys didn't know, Snap One owns Mitchell, and this is their version of Mitchell. It's no different. This is an old DVD version. They used to sell them in DVDs. I'm only up to 2004. This is an owned version, not a rented version. Anyway, this Volkswagen, let's look it up here because I don't have to rely on my internet connection, which has been sketchy. 2002 Volkswagen what?
GTI.
I'm not sure which one.
Golf, I think.
GTI.
It was just GTI.
It was just GTI?
Yeah.
Okay. And we'll go under wiring diagrams, all, and then cooling fan. And I don't know if it had manual or auto AC, did I say, in the video? Let's look at the manual circuit. I think this is it. Okay. The discrepancy, what made me pause here and say, maybe I made a mistake in this video is, let's identification first, just to review what I said in the video. If you look at, hang on. That's what we need to figure out. Is this a pull up or pull down design? Here's what we got. We have a ink that doesn't want to work. We have a feed coming down here, right? There's a fuse that comes over this way to our switch, which means that is power and that is power all the time. You see that? It says hot all the time. Now, don't let this throw you off that there's a splice and goes this way. You know, what's the dotted line here tell me too about this circuit?
Others use that.
There's others that use that fuse too that aren't relevant to this diagram. Here's where our focus is. And this is good. This is good reinforcement because what's inside this cooling fan control module, there is nothing in here. We don't know what anything is. But we do. This red with the yellow wire is a switch input signal. This red with a white wire goes where? Oh, that's why. Hold on. I think I might have just figured that out. The red-white goes multiple locations. I should be switching my color here because all I'm doing is confusing this. Okay. In the diagram, I had mentioned with my son that I walked in and I heard me say, that's kind of weird, I heard me say that,
This is weird.
that if we only want to jump that momentarily because it will get hot. I said that in the video, and it's been a while since I've seen this, so I'm thinking to myself, that contradicts what I'm teaching you with switch inputs, right? A switch input is just a signal. It's not controlling anything. It's low amperage. Well, apparently, only one is the switch input signal. That's this one. This would be the switch input. Oh, you guys with me?
Yeah.
And the one that I just jumped in the video was the red to the red-white. The fan ran. So I believe that red-white wire, I have to follow it, goes down to the fan motor itself. Let's take a look. But back to our switch inputs for a second. Do you see that this is a pull-up design? Do you see the difference in it? When we do identification, what I've said to you guys is you follow the wire that doesn't go to the computer. We'll tell you what's in the computer. So this red-yellow, I'm going to trace it over with black. Can you see that we have a question mark here? And it's open on this side. So what does that tell you? Nothing. It's a wire that goes to the computer. The only thing that tells you is that is the input to that circuit. We don't know circuit design, but we can know circuit design if we follow the other side. Now, these can get complicated when there's splices that go to different locations, but as we've been doing, you know, you follow a wire that's hardwired to a power. Everything attached to that is a power, and that means that that is 12 volts all the time. I don't care that it also goes this way. To me, right now, that wire doesn't even exist. As a rookie, that might throw you off a little bit. Make sense? All right, so I think we're good in the video. I thought there was a major correction, and that was because I was concerned about what I said with heat. But let's take a look at where this red wire goes. This red-white wire. And I'll be surprised if it doesn't go to the fan. It does, look. It goes right to the fan. When I jump that together, come on. Be kind. Okay, you guys, okay, there it is. I guess I'm drawing with my finger. When I jumped that red-white to power, what was I doing? I was running power to both fans, right? Can you see it? From the red wire that went to that fuse, and why is it running in low speed? Because it's going through a resistor. Cool? So I was correct in that it will get hot. So let's back up for a second. This is actually a really good comparison of switches and designs. This red-white wire, is this a switch input? Yes or no? This red-yellow wire, is this a switch input? Yes or no? Let's go back to the red-white. So the red-white switch, is it an input to the computer?
Well, the splices to the top. But
yeah, exactly. I should have looked at this before I asked you that question, because guess what? It's both, isn't it? It's a load switch and it's an input to the computer, to this controller. Do you guys understand, though, that the high current flow is going to go to my fans? And that this upper circuit, when it comes this way, it's just what?
watching.
This is a voltage sensing circuit. Does that make sense? That top wire is a voltage sensing circuit. It is a pull-up design. On a pull-up design, we just put a box and a ground, put your voltmeter there. That's pretty much it. On some designs, you may see that there's a resistor here that's going to ground, and that would just be to clean that signal up a little bit. If we just use a voltmeter as opposed to having it grounded, when the switch is turned on and off, this is with the ground, and this is without the ground. See if this makes sense to you on why we would add the ground internally. It's pressure that's like maintained in that wire, and so don't let that throw you off. What's inside the computer? A sensing circuit, a voltmeter, pull-up design. It's the same way here on this red and yellow. This is simply a switch input, right? Voltage sensing. This is also a voltage sensing circuit. Pull up. We just did a pull down on the door lock circuits on my Silverado. We did a pull up circuit on this cooling fan. I don't think you could be any further extremes here. Think about this: a Volkswagen cooling fan circuit or a Chevy Silverado door lock circuit. Guess what we're talking about? Same thing. Same approach. Switch input. Okay? All right, let's go back to my Silverado. We left off with the bypass test. Where is this bypass test in my text? Section 2. What? Is it already open? What the heck's going on here? I don't want properties. I didn't right click that. What the heck's going on? The bypass test. Where is it? It's down here. Page 8. Troubleshooting the circuit. Signal voltage measured at the switch, fixed low. Do a bypass test. How are we doing the bypass test? In my Silverado. We're right here, guys. I'm looking right here. Disconnect the switch. Touch on and off the signal wire with a test light to ground. What kind of test light? Yeah, I want to use an incandescent one. You guys all have LED test lights here. An LED test light would not ground that circuit. Was I safe? Let's talk about this for a second. Was I safe in this bypass test that I'm doing over here? Was I safe in just grounding that circuit? Does the switch ground the circuit? Let's talk about that. What does the switch do? When this switch moves over to here, isn't it grounding that wire directly? Am I going to hurt that circuit by taking a test light to ground, regardless of resistance of the bulb? No. If anything, if your resistance is too high, it's not going to work. That's all. And so you might be thinking, why not just use a jumper wire? Why not? How many wires are on this door lock switch? Let's look at it. How many of you think there's only 3 wires on this door lock switch? Now, how do we know there's more than 3 wires? Dotted line, very good. There's a dotted line. There are multiple wires on here. Do you think it's a real possibility you may jump the wrong wire with a jumper wire? Yes. Do you see why I want you to use a test light? It's your safety mechanism. Now wait a minute. I was told never use test lights on computer-controlled circuits. Guess what? You were taught wrong. Okay? Just stay with me the rest of the 8 weeks. Watch my case studies and you'll see I use my test light everywhere. It is my best friend. Okay? Can it get me in trouble if I'm not careful? Yes, it can. But if I don't want to use it, then I'm going to follow the manufacturer flow chart and just go have at it with your little flow charts. Or pay attention. We cannot half-ass this stuff. You do this stuff wrong, you can cook things, but your test light's your best friend. I promise you in this circumstance, you're not going to hurt anything with this test light. Do we want to use test lights on airbag circuits? Probably not.
No, definitely.
We don't want. Do we want to do bypass testing on an airbag? In other words, do we want the airbag to deploy when it shouldn't? Yes. Probably not. Okay. So I wouldn't recommend test lights on airbag circuits.
We need to test it though. Make sure it works.
Yes. All right, focus. All right, so remember where we were in this scenario. We were at 0 volts on this orange black. What was our next step? What was our next step? Unplug this. This wire went to 12. You guys understand that that's it. We're done. Needs a switch. We did the bypass test to confirm it. That's where we are. What if we disconnect this switch and it stays at 0 volts? Then guess what? It is not a bad switch. We have an open or short to ground in this circuit. So now at this point, unfortunately, we have to take a measurement up here at the computer, voltmeter to ground. No, we do not need to use an ohm meter. Use your voltmeter. And this is what I walk you through in the text in my book. 12 volts here. If I read 12 volts here and I read 0 volts over here, there's only one possibility, and that's an open in the circuit. An open would cause that. A short to ground in this circuit anywhere on this wire would pull the voltage down to ground. Here and here. Wouldn't matter. Both sides of the circuit would be 0, and this would be 0 here if it was a short to ground. You guys follow? So if we read 12 at the computer and 0 at the switch, we are done. We have an open, fix it. If you read 0 at the computer, well, I'm sorry, let's cross that off the list. an open signal connector, we'll kind of lump that together, either connector or signal. If there's another connector in here, we have to map out where that goes and find our problem. If we see 0 at the computer and 0 at the switch, we cannot. I thought I had bad computer in here. Where's it at? Didn't I have bad
You
computer?
did, it was below all that.
It disappeared on me. Short to ground and signal down here. This should say bad computer, right?
Yeah, with a K.
Oh yeah, with a K. Yeah, it disappeared.
You erased it.
You guys follow with me that we have two options left. We either have a short to ground in that signal wire, or we have a bad computer. Should we know how to use our ohm meter now? The answer is yes. I need to measure this circuit for a short to ground. Now to simplify this, I'll just draw it here. I have the wire isolated at the switch and the computer. It's unplugged here and it's unplugged here now. I have to isolate the circuit. When we do ohm checks, that's what you got to do. Connect our ohm meter for a short to ground test. Where do the leads go? Very, very important. Guys, listen. If this is a $2,000 computer, the difference here is going to be we either need a $2,000 computer or we have a 50-cent wiring repair, and we're about to use our ohm meter properly to make the right call. Is it now time that you know how to do a short to ground test with your ohm meter and know for sure that you're doing it properly? Okay, where do we connect our leads? No pressure now.
Everywhere.
Where do the leads go would be where we start before we talk about what scales we want to be on.
Red one stays the same, correct?
Okay, yeah, well, red one goes where? We were over here when we did our last voltage reading, so I like that. Red one can stay there. I agree. Computer's now unplugged. We're back probing that same wire like we did in my, which video was that with a bad block ground? Was that a Toyota Echo? Is that what that was? With the bad block ground, where you saw when I did that ohm check, I did a voltage reading and then I did an ohm check right after that. Yeah, same pin. I'm already there. Where's the black lead go? How many of us say to the other end of the wire? How many of us say to a known good ground? Very nice. I saw no hands for my first question. That's great. If we went over here, what kind of test is that? Is that a short to ground test or is that an open circuit test? That's an open circuit test. And if that wire is shorted to ground, it doesn't matter. That meter will put out a trace. It'll blow right past that ground. Why? Because it's looking to get back to where it came from. And it's going to show you 0 ohms and you'll say that's a good wire. Wrong. $2,000 mistake from using your ohm meter. Come back. So don't want to go there. Where's my black lead go? Known good ground. If that wire is shorted to ground, ohm meter will send out a voltage trace that will travel through the frame and back in this way. And a bad reading would be 0 ohms. Agreed? The only good short to ground test reading is what? OL, but not just OL. OL K ohms? Regular ohms? M ohms? M ohms. OL M ohms equals infinity, guys. Your infinity symbol, that's not accurate the way I drew that, but again, meters won't tell you infinity. Questions? See the steps, processes involved? There's other ways to do this. Can we use a test light? Can I take this circuit that we suspect? So I have a computer here, the wire is isolated, and maybe here's the switch over here. Could I take a test light to battery positive and rely on that light and say, okay, if that light doesn't light, remember it's wait, what design was this? This was a pull down, fixed at 0 volts. Yeah. If that light lights, that would tell me that I have a short to ground. Can I do that? The answer is yes, but, and there's a but in there. I have a situation, I have a case study that, here, let me just share it with you. I'll do it here. It's an old GM ignition control module and engine control module, ECM. These guys talk to each other, and I told you at the beginning that we're all over the place with this. And on page 2, I talk about PCM to igniter, ignition module to PCM. So module to module communication, we're on the same subject. And by the way, Jorge told me before that we were off a page when I was talking. We were, because remember when I added a page in here and it stayed, there were 2 page 3s. Well, apparently later it changed to a page 4, and that we were off. So in the last segment, we were off a page. It wasn't that my book's messed up. It was that I screwed up here in adding that slide. That's why our numbers were off. So I apologize for that. What are we doing? What's an ICM? That's ignition control module. Did I spell that right? Mental block.
Module.
That's supposed to be module, having some ink issues. Are these two guys talking to each other? Yes, they are. Here's a little bit more on this ignition module, just so we have perspective. There is a pickup coil, also known as a crank sensor, that will feed into this module. It is an AC sine wave. Well, computers don't operate well off of AC voltages, as we've learned. So what they put inside these is analog to digital converters. And what an analog digital converter will do is take a sine wave and convert it into a square wave. Okay? So that is what's riding on this wire. Computer is going to use that signal for RPM. This is my RPM input to the engine computer. You guys with me so far? We have an on-off signal, high-low. It's a pull-up design. And these are difficult. You can't determine electronic circuit switch inputs by looking at a wiring diagram. Why? Because you see a box here and a wire here and another box. Can you tell me circuit design? No, you can't. Circuit design is going to involve disconnecting one of them, say the ICM, and with the key on, measure the voltage here. It's 0 volts on this wire on a known good circuit, this being the PCM. So what's that tell me about the ICM? The ICM is sending the square wave in this direction in a pull-up design. That's my perspective going into this vehicle. So here's what we would get in the early years. These ICMs would fail in that they would control the coil, because they would. Did I write pull down? Did I just erase it? What? Did I actually?
You said pull up.
I said pull up and wrote pull down.
I
Wow. Somebody needs a break. I think it's me. No, that is not a pull down. That's a pull up. I said pull up though, right?
You did say pull up.
Wow. Sorry about that. Somebody got to catch me on that. Hey, Danner, you're not making any sense. You said pull up and you wrote pull down. Pull up design.
Should have ate something at lunch.
I should have. I haven't eaten anything yet today. Now, where was I?
Snickers?
No. Not yet.
Soon.
Soon, yes.
Yes. All right. Ignition module controlled the ignition coil directly. So the way that this system worked, this was, if you guys want to, you can do this on your own. I have a video. It's called a bypass ignition system. Bypass ignition system. If you type in bypass ignition on my free channel, this video will show up and it'll give you a more in-depth of this. Right now I want to focus on the switch input part. You guys can watch this on your own. On this design, I can potentially have spark, so my coil fires, and the injectors do not. So fuel injectors are controlled by the engine computer, and the example is no injection pulse with good, check mark, good spark. You don't have to know a lot about this system to know that it cannot be a crank sensor or pickup coil problem. Right? Look at the picture. What does that module need to work? It needs a signal. That signal is there. I have spark. I have no injection pulse. So this is common. These modules would fail. Believe it or not, you can have a bad ignition module that has good spark and you still need a module because it did more than just that. So these modules would fail and they wouldn't send this square wave signal to the computer. It'd be a flat line. And so the test was to take a test light and touch it on there to battery positive. And what you would do with that is you could make the injectors fire every time you did that with the key on. And if they did, that told you your computer was fine. Guys, I'm just pointing this out because I had one that had a Viper alarm system wired in here and I didn't know it. Viper. What do you think that alarm system did when it was going off to that signal? Why would we tap into that RPM signal?
It cuts it in ground.
It would pull it to ground. Okay? It would quote short it to ground. You see what I'm getting at? All right, and here's the lead into this, or the tie-in. I said the test light might not be a good tool for this sometimes. Here's what I did. This is a 0.5 volt square wave. When I take my test light to battery positive, it's 12 volts, so I'm actually putting a little more in this circuit than it should be. Not concerned about this. It's a sensing circuit. I've done it for years. We'll talk more about that variable later. And every time I did this test, number one, my test light did not light. So this wasn't lighting, which we don't want it to. And number two is my injectors fired when I did it. So I told the garage owner to put a module in it. He calls me back 2 hours later. The new module doesn't work. I told him to put another one in it. That's how confident I was in this test. I've done this thing 100 times. He puts a second module in it, doesn't fix it. So I go back to the car, look at it again. I'm trying to monitor this signal, put my scope back on it. Originally I was on a 14 volt and I saw a flat line. This time I looked closer at that line and it looked like maybe that line had a little bit of up down to it that I didn't notice before. So I took my scales and I dropped it down to a 1 volt scale and it really picked it up now. And I had a signal, guys. It was only like 200 millivolts. Should be 5. Long story short, the Viper alarm system was the equivalent of a 900 ohm short to ground. When I put my test light on there, the reason I said maybe we don't want to rely on a test light for short to ground tests is what we said is test light connected. If test light lights, that wire is shorted to ground. If the test light doesn't light, the wire's fine, but 900 ohms is not enough to light my 12 volt test light, so the light stayed out. And the tool to find that was my ohm meter. This is an example of when the ohm meter would be your friend. I just shared that case study with you for 2 reasons. 1, we're talking about a pull-up design digital signal. 2, to show you that the test light is not the best short to ground test. I got burned on this one. Bad call. It was a Viper alarm system. I cut the wire to the Viper alarm system and the truck started right up. The owner didn't even know it existed. It was a work van he bought and he's had it for years and never had a key fob for anything. Didn't even know it was there. So I got rid of it. Right? Just cut that wire, fixed it, and left the rest of it alone. I didn't care. It's not my job. I got it running, didn't I? So, good lesson there on that. Any questions? Okay, last part is the rest of this, and then I'm going to break from here. And did I close that other? Oh no, we're still there, aren't we? I just opened up a new page. Let me give you the rest of this circuit. Hopefully I saved it. I'm gonna close it and reopen it. Okay, cool. We got rid of all that crap. Operation of this. Let's just do that real quick. The switches, guys, again, do not control anything. What do? did the switches on this one control anything? On this 94, what did the switches do? They controlled the relay, didn't they?
Yeah.
And this one, what are these switches doing at the bottom? Bottom left and bottom right. They're just signals to the computer, right? So the computer's controlling the door locks. And let's take a look at that. We still have some relays up here, don't we? The nice thing about this is the tie into section 3. Section 3, the computer will switch power or switch ground to components. And that's really what that's all about. And that's really what this is right here. This top part, these relays, the computer's controlling it. Can you see the lock signals here, 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 and here? We have multiples, don't we? I'm sorry, not signals. Lock control. See the lock control and then unlock control. Do we want to do this now? I don't think I do. I'm going to save this. I think it's a new topic, and all I'm going to do is lose you guys right now, and I can see it in your faces that we need to wait. We need to wait on this. I want to do it, but I can kind of gauge a class and gauge a group, and I'm saying I need to wait on the second half of this and show you how it operates when we introduce the power and ground side switching. Let's stay focused here. Any questions on these being pull down design switches? Is everybody comfortable with that? All right, so we kind of are up to that. We handled the intro, the pull down. We really did the pull up design with that Volkswagen. Identification, we can do it with a diagram. We can do it with a voltmeter. I want to show you guys that, but I'm not doing it now. I want to move to that no start to give you guys a little bit of break from this. Just want to find a stopping point. Hang on. We did half of this flow chart, which would be a lot of these pages where I'm walking you through this. Yeah, you know what? I'm going to stop there, and we'll come back to this maybe tomorrow. I think for the rest of today, if you guys don't mind, you can help me pull this Jeep in. Not pull it in, we have to push it in. It's a no start, and we'll maybe run into some things that are related. Guys, listen, if this Jeep ends up being a crank sensor problem, guess where we are? Jeeps use Hall effect crank sensors, and we're right back into our switch inputs again. I may end up doing a little bit of the theory of the electronic design if it ties in with this Jeep. Let's see where it takes us.